Hello, everyone. Good morning. Dear authors and invited guests, welcome to Technical Session 1A. Myself, Ishita Sauryan, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2024, Pune, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event is organized today in Pune, India, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th of January 2024. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we'll have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the chair for this session. We have with us Dr. Priyanka Sharma, an experienced educator and trainer in the area of lecturing and technology with a trace record of working in higher education industry. PhD from IIS, deemed to be university, in field of web mining, published various research papers in journals of reputed organizations, including IndoScience, IEEE, Springer, Elsevier, and Taylor and Francis. Teaching experience of 14 years in University of Repute in Jaipur, Rajasthan, member of editorial board of various journals, and has even organized special sessions in international conferences. Currently, she works as an assistant professor, selection grade CS and IT, IAS, deemed to be University, Jaipur, India, also doing a part-time research in data science. We welcome you, ma'am.
Thank you, Anisha.
Now, we will be beginning with the papers. We have our first presenter for the day, Anirudh Sitaram, with the paper titled A Marker-Based Augmented Reality Application to Teach Chemistry to Indian Students. You may please start with your presentation, sir.
Yeah, hi. Am I audible?
Yes, you are audible.
Yeah. Yeah. So is my screen visible?
Yes, sir, it is visible.
Yeah. Okay, so hello guys. I'm here to present my paper that I've written with three of my professors, a marker-based augmented reality application to teach chemistry to Indian students. So let's go over the methodology I used so that it all makes sense towards the presentation. So I start off with creating research objectives and identifying the problem. And I go through the entire ethnographic research phase and end with creating requirements, which help me with creating my design intervention. So let's talk about the research objectives. So the first objective was understanding student challenges in chemistry education, assessing the impact of limited laboratory facilities in schools, and evaluating factors affecting student engagement. Then I went on to review a lot of research papers, patents, and articles. And I found that in Rajasthan and Telangana, there's this common problem of limited laboratory facilities. And it's also a common problem in terms of the global perspective in especially in African countries. Then I went on to look at how practical or experiential learning can have an impact on the way students you maybe uh, uh, do well in their tests, or maybe they don't do well in their tests because of this practical learning. And another thing that I found when I was doing this was how important motivation is, and how gamification, which is basically using game design elements in a non-game design context, to enhance the experience for users. And I also found a few solutions in the XR space that has helped students before with other subjects. So this is the primary research I did. So I conducted interviews with 8 focus groups with students, and 1 focus group interview and 3 personal interviews with teachers. And the most common thing I got told from the students was that they had challenges with visualizing the chemistry experiments, and how the limited laboratory facilities forces them to solely rely on traditional teaching methods. And the teachers also expressed a similar concern on how they aren't able to portray their skills as well because of these limited laboratory facilities. So then I created three requirements with all of the insights I had. Students must be able to visualize chemistry experiments easily. Students must be able to perform chemistry experiments, and students must feel motivated to perform chemistry experiments. So this is where we reach the brainstorming phase. So for each requirement, I brainstormed a bunch of ideas and combined them into three different concepts. And I rated them based on how well they would do with each requirement, with concept two in this case coming out on top. So then I quickly storyboarded the selected concept to understand step by step how the stakeholder, which in this case is the students, would use my app. So this is the smartphone application. So in screen A, you can start off by choosing your educational board. Then on screen B, you can choose your particular grade. In this case, it starts with sixth because ICSE has chemistry starting from sixth. And then these are all the different chapters within the practical section. And so let's say you chose recognition and identification of HCl. Oh, sorry, recognition, identification of gases. You get all these gases that are taught in ICSE. And let's say you pick HCl. There are three different ways to recognize HCl. So each different uh, sub-experiment or way to recognize is a sub-experiment. And so you perform each of them one by one to unlock a mystery chemical, which is basically the gamification aspect of this app. And so here, if you see here, there's a perform in AR button. So that would lead you to the AR prototype. So this is again for the HCl recognition. So dipping litmus paper in HCl and dipping a ammonia dipped rod in HCl, and finally pouring the silver nitrate solution in HCl. So, and this is fully interactive. So I've created this on Unity with a plugin that allows you to move objects and manipulate them in the 3D space. And then I went on to testing the prototype. I started with a pilot test where I wanted to test whether it was satisfying all the requirements, which it did. But one thing that the students did tell me is they weren't aware of how to use it at first, which is why I added this text later. So in the initial prototype, it wasn't present. So that helped me iterate my solution, and then I tested it with 19 different students where they all validated the solution. Now let's talk about the backbone of this entire research. So this is a framework that aims to enhance educational experience. So the integration of technology, of course, with XR, engagement, which is gamifying educational content, and standardization, which is that it should cater to multiple educational boards and their syllabi. Now let's talk about the impact of the solution. So I compared my app with two other apps that I found on the Play Store and App Store. There's very few of them that uh, can be even remotely dubbed as interactive experiments. So Chem Arcade, which is my app, clean sweeps the other two apps in terms of interactivity, standardization, and gamification. And now let's talk about how I would implement this solution with maybe schools that don't have the funding. One solution that I did think of was a collaboration with NGOs. If I was to scale this up as a business, I would collaborate with the NGOs to provide these digital devices for helping these schools out. Now, the limitations and future work. So, of course, the one thing is that I've only explored chemistry right now because that was a main focal point. And all of my testing data and interview insights are only from schools in Bangalore. So, other schools in other parts of the country might face different problems. Uh, and one thing is that the app part that you saw was created on Figma, which is more of a mock-up, but the AR part is the only part that has been developed. And as far as future work is concerned, making the application more accessible for students with disabilities, of course. And these are insights that I actually got from my pilot test, sorry, where they told me that there are experiments where sound is involved and also scent is involved. So I figured I would also want to implement audio augmentation technology and digital scent technology if I was to scale this up. So thank you.
Thank you, sir. We'll be proceeding with questions.
Yeah.
Anirudh, tell me one thing. Why did you focus on chemistry only? I mean, is it your forte or something?
No, ma'am. It started off with looking at STEM subjects first.
Hmm.
Then I, based on my personal experience as well, I've noticed that at least the school I studied in, even if there was a lab, students are generally not allowed. And so I thought I would dig deeper into this. And when I did do the interviews, they all mainly told me about chemistry rather than physics or biology. So I thought I'd take that as a focal point.
So you focused only on schools, not on colleges.
No, ma'am, because for now, 11th and 12th, at least the schools I went to, they didn't have 11th and 12th. They stopped at 10th. So it's mostly middle school and high school.
Okay. Okay, fine, Anirudh. Thank you.
Yeah. Thank you.
Thank you, ma'am. Thank you, sir. We'll be proceeding with our next presenter for today. Paper presenter Sagar D, with the paper titled A Study on Non-Invasive Diabetes Causing Variables and the Convariance Relationship in Diabetes Prediction Using Machine Learning Algorithms. You may start with your presentation, sir.
Sure, ma'am. Thank you. Yep, good morning all. So today we are looking at the work that was done in Ramaya University. Study was based on understanding diabetes prediction using non-invasive methods using machine learning algorithms. So the flow of the presentation will be, it will start from introduction, background theory, method and methodology, results, outcomes and analysis. So the study which was conducted by International Diabetes Federation in 2022, the report stated that around 90 countries, across 90 countries, over 5,000 distinct groups had a diabetes and the population over 476 million individuals. And if I look at on the global scale, it was estimated to be around roughly 537 million patients in the adults age of 20 to 79 age range, while estimating growth trajectory showcasing around 643 million by the 2023. And it has observed that using the machine learning algorithms, we can predict this diabetic symptoms in an earlier stage, and we can avoid and health complications in a crucial stage. So the background theory, we need to understand before applying machine learning algorithms, we need to understand exactly what this term diabetes means, how it is developed in humans, and what exactly causes the symptoms. So when human consumes meals, the food is converted to a glucose in a simpler terms. It is used as an energy for our body's functionalities. When there is a key term called as insulin, which is produced by the pancreas, acts like a key, allowing glucose to be absorbed by your cells. But the problem arises when the insulin is not produced properly or it is not being used properly by your systems. When insulin is not produced properly, it creates one form of symptoms, and when it is not getting utilized properly, it creates another form of symptoms, so leading to a general called as diabetes. So there are two specific variations in diabetes. There is called as type 1 and type 2. Type 1 generally is caused by autoimmune diseases. It means your own body cells attack your insulin cells, causing deficiency in the insulin cells, leading to what is it? And deficiency in the insulin by leading to diabetes, sugar or glucose absorbing capacity reduced in your body cells, leading to increase of the sugar levels in your bodies and in your urine. In the diabetes 2 type is little bit less aggressive compared to type 1, because in type 1 what happens is it is genetic based and environmental triggered based, whereas in diabetes 2 it is generally caused by lifestyle. It might be in terms of which kind of foods we use and our body type and things like that. So predicting exactly one specific reason why the diabetes is developed is quite hard for us to work with. There are multiple reasons. It might be from family history, it might be from overweight, it might be with respect to environmental things like that. So the study is focusing majorly on non-invasive parameters. Hence, we are looking at the parameters which are influencing in terms of non-genetical side. So for the study, we have considered 8 specific parameters or features, stating from pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetic pedigree function, and age. Why we have considered these are because these are can be generated and can be stored and utilized for further studies. Here, glucose normal range is estimated to be roughly around less than 100 in a normal, male human, whereas the blood pressure it is estimated to be less than 120. In the skin, the thickness is roughly around 0.6 mm to 2.6 mm is considered to be a normal range, whereas in insulin, it is considered to be somewhere roughly around 5 to 15 micro unit of insulin, and BMI is roughly around less than 25 is expected to be normal range. In a diabetic pedigree function, it is estimated to be range somewhere below 2.24 is acceptable. And the age range that we have considered is roughly around 22, 79 or 80. So this is a modeling for modeling methods that we have taken into consideration. First is the pre-processing part, second one is the training part, and then third segment we are going to testing part. So these are some of the algorithms that we have considered for comparison purpose. We have considered random forest classifier, we have considered decision tree classifier, we have considered XGBoost classifier, and we have considered SVM classifier. So out of the results, what we have observed is that random forest gives a little bit better results when compared to other three. But again, it depends on individual test cases. In the random forest, unit level test cases were giving better results, whereas in terms of group or in terms of continuous evaluation, random forest was not giving that much accuracy. But compared to others in an individual test cases, it was giving 79% accuracy, whereas decision tree was giving 76%, and XBoost was giving 74%, and support vector was giving 77%. When overall comparison with respect to training and testing came into picture, training, most of the models stood up to the requirement other than the SVM. But in testing case, every algorithm had a little bit of a drawback, but a major result was from 79% in terms of random forest algorithm. In the analysis part, we observed that when overall comparison again and again repetitive cycles when it was done, SVM had a better result compared to random forest, and random forest was somewhat consistent, but it was not giving highest accuracy. But whereas SVM was not consistent, but giving at some specific terms a little bit better results compared to decision tree or any other algorithm. So these are the references. Thank you. Yes, ma'am, done.
Sagar, finally, which algorithm did you choose? Random forest or SVM?
Ma'am, that was a debate between like which kind of applications you are trying to look for. If you're looking for single
So it was a
test cases,
kind of comparative analysis that you have done, right?
yes, ma'am.
And why did you choose only one particular category of diabetes? You could have chosen all, no?
Yes, ma'am. The problem was that like genetic means it goes a little bit more invasive, and the records that need to be made were not possible for us to acquire.
And
This was
how
a
many
general.
records did you analyze?
around
Sagar, your voice is not audible. How many records did you analyze? Anisha, I guess there's some problem in his network. You may proceed with the next paper.
Okay, sure, ma'am.
Sure, ma'am.
yes, ma'am,
Thank
can you
you,
hear me?
Sagar.
Yes, ma'am, thank you.
We'll be proceeding with our next presenter, paper presenter Janvi, to present the paper titled Advancements and Challenges in Fully Automated Online Proctoring Systems, a comprehensive survey of AI-driven solutions. You may start with your presentation, ma'am.
Hello, good morning. Am I audible?
Yes, ma'am, you're audible.
1 second, I'll just share my screen. Thank you. Hello, is the screen visible?
Yes, ma'am, it is visible. Please continue.
Good morning, one and all. This is Jahnavi, and I'm a research scholar at NIT Silchar in the Department of Computer Science. And today I'm going to present a literature survey of my problem statement, which is the advancement and challenges in fully automated online proctoring systems and a comprehensive survey of the artificial intelligence-driven solutions. So these are the contents of my presentation. Abstract followed by the introduction and then overview of the available fully automated proctoring systems, and then what are the research questions and the challenges that I have identified, and finally I would conclude the discussion. The education and skill development has changed throughout the years, and there have been very evolving expectations, and especially with this COVID situation which has come up, the teaching learning process has to be remained contemporary, and it has to always go with the changes and challenges that are coming. The transformation in the education system, particularly in the reliefs of the examination, assessment, and evaluation, has brought these changes. Because of this, a lot of automated online proctoring systems have been designed for better assessments as well as the evaluations. And for this, to understand what are the various available automated online proctoring systems and which is the better one and how we can make it into a next best one, we have conducted a comprehensive literature survey on the available systems. And the main aim of this paper is to provide the researchers a better understanding of what is that is available, what are the potentials of the AOP system, why it is required, and what can be done in the further. What the greatest concern of any teaching learning method is that the better assessment and evaluation of the students. And when we are talking about the evaluations, first the assessments has to be done properly. And these days it's morely like turning into the online systems. The biggest challenge is to how to onlinely monitor whether the students are without any cheating, are they performing better or not. And for this we can employ the proctoring skills. There are usually the 4 types of the proctorings. The first one was the no proctoring, in which the traditional classroom examinations where the students used to come and a teacher used to be without any monitorings. And then next is the manual monitoring, in which the cameras were installed in the examination hall, but still again this requires the manual part, because the faculty, the teachers or the staff has to manually keep monitoring through these videos. The next was the semi-automated online proctoring systems, in which 360 degrees cameras or robots were installed, and they were able to monitor it, but this turned out to be a more costly one. And the next level of the one is the fully automated online proctoring systems, where we use the various AI techniques such as face recognitions, face detections, eye gaze estimations, head pose estimations, gadgets and mouth detections, all these. The primary contributions of these papers were majorly outlined as to analyze the strengths and weaknesses of the available online automated proctoring systems. And the next is to explore the research questions and also provide the potential solutions for enhancing the effectiveness of the proctoring systems. And the next is to identify the areas for the improvement, and we can guide the further researchers who are going in this particular domain. So these are the various automated proctoring systems that were available. We have one, the first is the Vardhan AI proctoring system. In Vardhan AI proctoring systems, we had multiple modules like face detection, eye gaze detection, examining the count. First one is majorly where you can identify number of persons that were there, and if they were trying to speak anything, that was usually identified by their mouth open and close things, and other gadgets like phones were also detected in this. The next is the automated proctoring systems. In automated proctoring system, we have face verification. The major difference for the Vardhan AI proctoring and the automated proctoring is that in Vardhan AI proctoring, we had face detection, but it did not recognize whether the person who is taking the exam is the same one who he has to be or not. Whereas the automated proctoring systems has face detection as well as the face verification also. And in this, the eye gaze detections phone, and rather than trying to say whether the people were speaking using mouth open detection, this thing has been done by using this speech detection. The next is the cheating detection method, and in cheating detection algorithm or the as architecture, the authors have detected the cheating behavior of the examinee by calibrating their eye gazes. In this, WebGazer, which is an JavaScript-based open source library, is usually used for monitoring the eyeballs, and using that they were able to predict whether the particular person who is taking the exam is looking at the screen or he is looking away from the screen, and in this way, this cheating behavior was predicted. And the next is the attentive net. The authors of the attentive net have detected the cheating behavior by using cascaded neural networks, which was used for detecting multiple examinees. So in the screen, if they detect someone else, that was also detected in this attentive net. And they have also used a sequential layered model, which is liveness net for spoofed faces. And they have also solved the PNP equations for estimating the head pose, if the to check whether the examinee is turning his head towards any other thing except the screen. And in this, the authors have identified the instances of malpractices only if at least one face is aligned. If more than one face is aligned, it was not able to predict it exactly. And then the next was the Proctor net. The Proctor net was actually an extension of the attentive net, in which, along with the face detection, the face recognition module was also added to it. And for face recognition, they have used the Inception ResNet based architectures. And the authors here have estimated the eye gaze by using a stack our glass modules, which through which they have generated the heat maps. And rather than using the previous in cheating net where they have used WebGazer. And here they have also tried to predict whether an examinee is trying to speak by again using the mouth open detection, like they have the used one in the Vardhan AI proctoring systems. So these are the various architectures of the automated proctoring systems that are available. Throughout the research, these were the research questions that we have identified when we have done the literature survey. The first thing is that what are the attributes that has to be considered for any fully automated proctoring systems? And then what is the literature of these various attributes. And next is the what is the future of these fully automated proctoring systems. And all these were discussed in the next slides. The first is the what are the various attributes, and these are the certain attributes that were considered, and we have also aligned with the architectures that are available. So this five architectures that we have discussed previous, and the attributes that are available. So you can see that every architecture is missing one or the other, and to make it better we have added something, all the things in the proposed system. So like Vardhan AI system, it has face detection, but the face recognition or the user recognition is not there, which was present in the automated proctoring systems. And then again, speech recognitions was present in the automated proctoring systems. The automated proctoring systems did not have the face spoofing, all these things. The next research, yes, ma'am.
I have a question. How did
Yeah.
you identify these attributes?
Ma'am, the architectures, all these architectures, they have discussed about one or the other attributes, and we have combined all of them, ma'am, consolidated them.
No, because there should be some method of identification of attributes as well, no? Because I can see that you've selected somewhere upon around 10 to 12 attributes, right?
Yes,
And
ma'am.
then you have performed this comparative analysis of your various systems, and then you have proposed a new system,
Yes, ma'am.
listing all the attributes. But then how did you identify these attributes? Because that again is an important task.
Yes, ma'am. But as I said, what we have done is that there were certain literature survey papers which were discussing on the smart educations and the
So then that
interactive
also you should
technologies.
mention, that also you should mention over here
Okay, ma'am.
that
The references. Okay,
from
ma'am.
these papers, we
Papers.
have identified these attributes. Because
Oh, okay,
when you
ma'am.
are doing this sort of research, the
Yes,
selection
ma'am.
of attributes also should be mentioned.
Oh,
That
okay.
how you came to the conclusion that these are the major attributes which should be
Attributes.
considered.
Oh, okay, ma'am. Sure.
Okay.
So we were having actually few papers like smart education and what are the automated proctoring systems using computer vision techniques, and there were two literature survey papers. They have actually also proposed that these are the good set of attributes. So maybe I should have referred them here.
Yes, you should have
You should,
referred them so
yes, ma'am.
that, I mean, that is always the good option because
Option.
otherwise the person does not come to know how did
Come.
you identify the attributes.
Okay, ma'am. Yeah. Thank. Can I continue, ma'am? Next.
Yeah, please.
Thank. So the next research question that we have identified is what is the literature of the various attributes, and here we have represented these. So here we have provided the references which one was discussed in which paper, but how the attributes were selected, which we missed it. So the major attributes like face detections, it was usually done by using multi-layer feedback. And again, Weiler-Jones algorithm is one more, which provided an accuracy of 94%. And we also had this faster RCNN based frameworks, but compared to this, the DNN and the Weiler-Jones have given more accuracy in the case of the face detections. And even head pose detections were also done by using the multiple algorithms. And we can see that this CNN and adaptive gradient methods have given us accuracy of which 73.9% here. And the gadget detections. So these are the multiple, and we have provided the references at the end, which attribute was discussed in using which methodology and what was its metrics and the accuracy and what is the data set that was used to test whether it's working or not. The next one is the what is the future of the fully automated proctoring systems. So under this, these are the certain challenges that we have identified. The first is to detect the examine phase in the frame. So for any automated online proctoring systems, it's suggested that first it has to start when the examinee face is detected. If the examinee face detection is lacking, it's first it has to be alerted, and then next is to check the aligned faces in the frame, and the next is to verify the detected faces for user identification or user recognitions, and next is to detect if the examinee's face is fake or real, and the next is to check if examining is speaking by others by either detecting the mouth open or close, or else by using the speech recognitions. And next is to alert the proctor if examinee is not viewing the screen by estimating the head pose and the eyeball track movements. Here we can also even provide a certain papers have also suggested to use certain mechanisms where you can block the other browsers, so that they can just only go through the browser in which they're taking the examining. And next is in the above case where we are trying to track the eyeball movements and where we are trying to identify the head pose estimations, there are certain limitations because of the physical disorders of few examinees, and even these physical disorders have to be also identified, and it should be alerted to the proctor, saying that these are not cheating, but it's regularly the physical disorder of that particular examinee. And last, we would like to conclude that the detailed role of automated online proctoring systems, that is existing systems, and a comparison among the attributes is given here. The future of these systems is to check for malpractices or the cheating behaviors. Like first thing is majorly whether student is trying to move in and out of the frame, and if he's trying to speak to others, so that you can estimate whether if any other person is helping him to copy. And next major thing is to immediately alert the proctor in the precise time with high accuracy. And the researchers have ample opportunities in this to categorize the students based on various unethical behaviors. And there are numerous possibilities of exploring such attributes and detecting the instances and aligning the faces on. Thank you. And these are the references that were used in this.
Thank you, ma'am.
Thank you.
We'll be proceeding with our next paper. We have paper presenter Vedant with the paper title Creation and Deployment of E-commerce Magento Website in AWS Cloud. You may start with your presentation, sir. Sir Vedant, do we have you in the meeting? Ma'am Priyanka, since we do not have Sir Vedant, can we proceed with the next presenter? We'll be proceeding with the next presenter, Duroy Roy, with the paper titled Designing a Low-Loss Wideband Cylindrical Dielectric Resonator Antenna for High-Speed Wireless Communication. You may start with your presentation, sir. Sir Duroy, I'm afraid we can't hear you. So you're not audible.
Right now, I think.
Yes, sir, you're audible now. Please continue. Please continue.
Let's just wait. Stop video. Okay. So, what is an antenna? It is defined as a transducer. Okay. So it can actually converts electrical power to wireless, some sort of wireless energy. So antennas are generally made of metals that can actually radiate electromagnetic wave, but in our case, it is not metal. So dielectric resonators of the antenna. So as the name suggests, they're dielectric. They cannot carry current. They're basically ceramics. So DRAs, in short, with the support of the ground plane, metal ground plane, have received increased interest in recent years for their potential application, microwave and millimeter wave communication system. So it has some limitations like low gain and low bandwidth of microstrip patch. It can be overcome by this DRA. And analysis and studies of characteristic equation, radiation patterns, excitation methodology is made DRA popular. It was first invented by Richmond in 1939, back in 1939. And after that, 1962, Okaya and Berash, they actually developed the theory for this type of antenna. So how this antenna works? As you can see at the right of the image here, there is a ceramic block over here, this pink one, and the block is placed over a copper ground plane, and you can see there is a feeding probe inside the ceramic block. So what happens? The electromagnetic wave is introduced through this feeding probe, and it radiates inside the resonator. The resonators have some semi-transparent wall, semi-transparent to electromagnetic signals, and some of this resonated wave are actually transmitted out of this resonated semi-transparent wall. So this image was taken from a Hindawi article. So the features of DRA is like the dimension of resonators of the order of lambda 0 by epsilon root by epsilon r. That lambda 0 is free space wavelength, and epsilon r is the dielectric constant of the resonator material, ceramic material, non-conducting material. It is. The size of DRA can significantly reduce by choosing high value of the dielectric constant. If you take a value of epsilon r quite high, the size will be reduced. There is no inherent conductor loss, as this is not a metal, so there is no metal loss like eddy current loss, all these things. So this leads to, there is no concept of skin depth in this. So this leads to high radiation efficiency of antenna. So as there is no loss, it is especially suitable, this sort of antenna, for millimeter wave microwave setup. And it is fabricated, where the loss in metal fabricated antennas can be very high. And they offer simple coupling schemes to nearly all transmission lines used at microwave and millimeter wave frequencies. Operating bandwidth of DRA can be varied over a wide range by suitably choosing resonator parameters, what we are going to show. And use of multiple modes theoretically has also been successfully addressed by the researchers. Each mode of the DRA has a unique internal and associated external field distribution. Therefore, the different radiation characteristics can be obtained by exciting different modes of the DRA. So at a very high frequency, that's microwave and millimeter wave frequency, that is being used in today's 5G communications, like up to, it is designed to work at 60 hertz gigahertz frequency. But very high frequency DRAs display a very excellent characteristics, that is comparatively low metal loss. And so the 60 gigahertz frequency band system works from 57 to 64 gigahertz. So a 7 gigahertz bandwidth can be available using a DRA antenna. So we'll be working with cylindrical DRA. So here you can see there are various shapes of DRAs are available, like cylindrical, rectangular, spherical, etc. So we'll be working with cylindrical DRA just because of this facility, that it has a very low number of degrees of freedoms. Actually, you have only two parameters to control, that is the height and the radius. For other cases like this rectangular one, or for this hexagonal one, you have a large number of degrees of freedom. That is, the equation would be more complicated. So we are working on this cylindrical type of DRA. It was first reported in 1983 by McAllister, and then it was not actually researched upon. Recently, at the advent of 5G communication, these antennas are explored. So Sangiovanni and his group actually used annular ring configuration of CDRA to obtain large bandwidth. There are some recent works. In 2001, Kishk et al. Achieved about 33% more bandwidth using split CDRA. And all these references are there in the paper. So fractal ring was used by Shankar Narayan et al. In 2016 to once again to increase bandwidth, that's because this sort of antennas has low bandwidth. But I'm not going to read out all these references. So our work actually, the right side image shows you the structure. So here we have two, say we have one ground plane of copper ground plane around 2 millimeter of thickness. On the ground plane, we have this ceramic cylindrical piece, okay, in which you have inserted a coaxial probe, and the measurements of this cylindrical block is shown here. Its height is around 13 millimeter, and the diameter is around 12.7 millimeters. 1 inch diameter, and radius is over 12.7 millimeter, and its epsilon RD, that is this dielectric constant, is around 10. This coaxial probe actually simulated to be placed from this point, that is center point, at the extreme end, and we found this is the optimum place at, say, rho equal to this distance from center, rho equal to 10 millimeter, and the height of this probe at 9.5 millimeter. So for optimal position, we actually tried to find out the resonant impedance of this antenna, and the optimal place is where the resonant impedance is around 50 ohm. So after that, after this determined resonant, this point of this probe, what we did, we actually placed another this sort of block, ceramic block, on this first block having height h1, and we simulated the effect of this stacking of antenna, and then we have introduced, we noted the changes of the antenna parameters, the ratio of the height, that is h2 by h1 of the CD array. So what happens actually when the height is when the CD array is stacked? And then we deliberately introduced the AR gap, as you can see in the second diagram. There's an AR gap AG2 over here between two stacked materials, and we actually varied the thickness of the AR gap and recorded the concerning data, that is resonant frequency, impedance bandwidth, input impedance, and return loss. So this figure 3 and 4, this actually shows our experiment setup. So next, we got the results from the simulation setup like this. So this figure 5 shows you the plot of percentage bandwidth and antenna gain, the versus resonator height ratio. So we have this h2 by h1, we have changed the height ratio. We kept the lower one h1 constant and changed the h2. And we recorded the change of percentage bandwidth, the black line, and the antenna gain, the red line over here. So what you can see from here, that as the resonator height ratio increases, that is at the height of the top CD array increases, we get an increment in percentage bandwidth of the antenna. Okay, the antenna is increasing like this. And the antenna gain is also increasing up to some point, like where the ratio is equal to 1, that both the antennas, both the dielectric resonators are of same height. And after that, up to this, we get some linear change in antenna gain, and after that we have some fluctuation and deterioration. So we can take this point as an optimum point at which the gain and bandwidth both are increasing. So in the second plot, the figure 6, we can see once again we have plotted the resonant impedance and resonant frequency with the change of the air gap thickness. So as you can see, with the thickness of air gap increasing, the resonant frequency is also increasing, but the percentage resonant impedance is decreasing from like 56 ohm to like 49 ohm or something. Not that significant, but it is decreasing. So we want to stay somewhere near 50 hertz to get a very efficient coupling between antenna and the transmission line. Here figure 7 shows you the change of percentage bandwidth and antenna gain with the change of AR gap between the resonators. Here also you can see the antenna gain, that is shown in red line. It is actually decreasing. Okay, not that significant once again, but it is decreasing. And the percentage bandwidth is still increasing with the insertion of AR gap. So once again, we have some optimum point over here where the decrement of antenna gain is not that much, and the increment of percentage bandwidth is quite high. So at this point, we can actually have some sweet spot, and we design some antenna at this frequency. So this figure shows the 3 plots actually of single CD array, that is CD array 1 with no stacked element. Then the red one is stacked CD array, that is CD array 2 over CD array 1, the ceramic block 2 placed over ceramic block 1. And the blue plot shows you the stacked CDRA with the air gap inserted in between the CDRAs, like this one. So there's the air gap between the CDRA. So this is single CDRA. This is CDRA stacked CDRA. And the third one is when AG is some finite value. We have CDRA with air gap. And the plots we have, I can show you. This black one has a very low return loss in compared to the other two ones. The single CDRA return loss is lesser than the stacked CDRA version, but in this case, the frequency, operating frequency decreases. And in between, we have a very sharp return loss plot that is with the air gap of around 2.0 mm thickness. So we have very high Q factor. This plot is very narrow, we have very high Q factor. So this is very highly selective antenna. These are the comparison of data available in the three cases. So single CDRA of 30 mm height, stacked CDRA of 30 mm, that is H1, the first CDRA, and the second ceramic resonator of a 9 mm height. It gives you some bandwidth increment, like 2%, something like that. And at case 3, you have stacked CDRA with air gap of 2.0 mm, that is CDRA measurements are like 13 mm, 9 mm. And in between, we have a 2 mm air gap. In this case, you can see you have 5% of, say, incremental bandwidth. So it actually shows the data bandwidth change for three cases. So the graphic figure 5 shows that when the dimension of the radiators are nearly the same, the maximum percentage bandwidth around 30% is added. So the gain peaks at around 4.7, and the top CDRA height is approximately 130% of the lower CDRA height. So from this plot, we can get this data. Plot figure 5. The optimal dimension at which impedance is 50 ohm, as I showed you, the 13 mm and H2 9.5 mm, where R is the CDRA, the CDRA radius are kept constant at 12.7 mm. Both the CDRAs have same radius. So after determining the optimal height ratio, at which we get impedance like near 50, 55, 60 ohm, we conducted simulations to explore how an air gap modifies the responses of structure of antenna. So between the air gap with 0 to 4.5 mm we have simulated, there is a noticeable expansion of approximately 52% bandwidth, and approximate drop of 4% in antenna gain is observed. As you can see, the antenna gain is dropping, so there is around 4% drop of antenna gain also observed in this case. But nevertheless, for 5G antennas, like today's high frequency antennas has less antenna gain and antenna reach. Actually, as you know, 5G antennas are placed apart around, say, 1.6 to 5 to 3 kilometers apart. So they have very short range due to short gain. So as a conclusion, the simulation study shows the stacking narrowband cylindrical DRA antennas with an air gap between resonators transforms to them to wideband antennas. That is, you can have wide bandwidth to send a large volume of data over wireless communication. The DRA antennas offer advantage of by avoiding metal losses is only found in millimeter wave microwave radio frequencies, making them promising for 5G technology or in 50, 60 gigahertz or maybe in 6G. So they can deliver both broad bandwidth and high gain, facilitating high speed, low loss transmission. And despite the drawbacks like losses at lower epsilon R, recording a third dimension compared to 2D patch antenna. We have the microstrip patch antennas; those are practically used in nowadays mobile phone. But this DRA antenna is has a one dimension more than this 2D patch antennas. But still, it is a very energy efficient wireless communication device. For handheld devices, you need wireless energy efficient devices with no loss. The challenges in wideband communication includes loss management and the inverse relationship between resonant frequency and antenna size. So smaller antennas at higher frequencies can be very beneficial for manufacturers. So the approach used here, employing a CDRA to enhance bandwidth, is practical and easily fabricable, so offering a promising solution to the field. So these are my references, and thank you for listening to me. Any questions, please? Any question, please?
Ma'am Priyanka, would you like to ask a question?
So I think no questions. So I'm stopping this screen share.
Sure, sir.
Thank you.
Thank you. We'll be proceeding with our next presenter. I'd like to invite author T.A. Alga to present the paper titled Empowering Rural Entrepreneurship in the Digital Age, a Systematic Exploration of Social Computing's Transformative Potential Track, Technology Trends, Social Computing. You may start with the presentation, ma'am.
Thank you. Am I audible?
Yes, ma'am.
Is my screen is visible?
Yes, ma'am, it is visible. Please continue.
Okay, thank you. First of all, I wish to thank the SMARTCOM 2024 given this opportunity. And our title is Empowering Rural Entrepreneurship in the Digital Age, a Systematic Exploration of Social Computing's Transformative Potential Track, Technology Trends. So the significant advancement in social computing has been made since 2006. The social networking sites, blogs, wikis, email, content sharing website, etc. are the social computing platforms that are commonly used. And the entrepreneurs can identify their prospective customers, collaborate with them, and they conduct their online entrepreneurial activities through these social computing platforms. So they can help in the gathering, representation, processing, usage, distribution of information through these kind of social collectiveness that we can often refer to as social computing and social commerce. And the rural entrepreneurship plays major contributions to the economic development and also reducing poverty and also the upliftment of rural communities. So they are facing some problems, like they have faced problems in the inadequate access to resources, markets, information, etc. Apart from these challenges, the social computing provides the technology, communication, and information exchange. So the social computing networks can speed up the market information, and also they can keep up with the rural entrepreneurs can keep up with the changes in the market, and also they can identify the consumer preferences in an easy manner. So the online marketplaces and e-commerce platforms helps the rural entrepreneurs to reach the market globally without any geographical restrictions. So the social computing encourages the networking and collaborations among rural entrepreneurs because they can establishment of this partnership is also possible in this kind of social media. So there are two main research objectives that we are identified in the study. That is to evaluate the importance of social computing in rural entrepreneurship, and also to identify the application of social computing technology trends in rural entrepreneurship. So this methodology is systematic literature review, and for the literature review, there are certain inclusion and exclusion criteria were applied. The inclusion criteria is mainly the studies that is published in papers like conference papers, review papers, article, etc. were included, and these studies are in English language, and the studies is not limited to any the geographical area, because this paper concentrate on all the studies that were published in almost all countries, and the publication stage is limited to final. And the exclusion criteria is one is that the papers other than English language like German, Chinese were not considered, and also the search mechanism we are also find that in the papers where we are searching in the databases, the papers that is article in press, that is it accepted but not published, that papers are also excluded. And this is the search criteria: article title, abstract, keywords. And the search databases of search engines are Scopus, Web of Science, Dimension, PubMed, Google Scholar, and IEEE. And the keywords, initial keywords are rural entrepreneurship, social computing, digital age, and social media. And finally, we identify the keywords that is social computing, social media, social computing, digital, like that, in while referring the past literature. So initially 3312 documents were found, and after removing redundant documents, 2461 are found. Then after 402 documents were finally selected. These are the type of document. So we can move to the answer to the research objectives. That is, the internet usage encourages social networks, which turns encourages also the entrepreneurship. So this emergence of social media, smartphone, etc., were creates a huge impact in the entrepreneurship world. So these are called as digital technologies, and these are creating the emergence of new innovative business models, procedures, products in the market. So the rural digital entrepreneurs are aware of this e-commerce and internet marketing to reach the wider audience, and also they can encourage collaborative, personalized, and interactive engagement with the customers, especially with customers and other stakeholders. And these are social media based entrepreneurship helps them to increasing their income and also generating more income to these vulnerable sections of the rural areas. And also rural media presents the business opportunities, both men and women, without any gender disparities. And it also we can use this social media to buy and sell products. Through this we can generate earn income. And also the social platforms and technologies will promote the communication, teamwork, and information exchange. But they are facing certain limitations, like they have also facing the lack of expertise, resources, in the sense both financial and non-financial resources. And also they can interact with the mentors for assistance through this kind of social media for eliminating or for reducing these kind of challenges they faced. And these are the uses of social computing in rural entrepreneurs. These are identified from the past literature. That is, they can identify the customers, consumer research can be possible, market access, receive feedback, disseminate information, and they can also create brand awareness. So they make investments in social media through this building reputable website, and also they can concentrate on finding local solutions for the rural people. And they can identify the product or service that provide solutions to the specific community by identifying the consumer preferences, etc. So the rural entrepreneurs can make partnership to easily found and cure. Also they can identify what was the solution that is intended by the rural community, so they can make collaborations, information sharing, etc. So the success of rural digital entrepreneurs is impacted on this community involvement, digital proficiency, and innovative problem solving. So these success stories will motivate the next rural entrepreneurs to engage in this kind of social computing. So they can in the past literature, we can see that how rural regions may prosper in the digital era, especially through this social computing. And we are identifying such research gap, like there are limited number of studies that may investigate the role of digital platforms in facilitating the networking and collaboration among rural women entrepreneurs. So the studies are done, but concentrating on the rural women entrepreneurs are very less. And also the limited number of studies are in the past literature by concentrating on the challenges faced by the rural women entrepreneurs. And there is a limited number of case studies, longitudinal studies, and most of the studies are qualitative nature. We can in future we can apply this quantitative studies to identify the perception of rural entrepreneurs about the social computing and other digital platforms. So the policy implications we can draw from this result is that they are facing fewer obstacles. If government liberalizes the law like taxation, e-commerce, etc., they can eliminate these kind of obstacles. And also the continuous evaluation of how policies and programs that were applied in this rural entrepreneurship is necessary. And government and relevant organizations can provide priority to the digital hubs creation and also the incubators in rural areas. So they can it will help them to utilize this social computing technology in a better manner. And also these entrepreneurs in rural areas frequently have trouble in financing. So the creation of NJ capital funds, microfinance initiatives, or grants, etc., create this rural entrepreneurs assistance in a better manner. So the limitations while experience doing this study was, first of all, the smaller number of past literature specifically in this context was very less. Social computing and rural entrepreneurship studies are there, but the importance of social computing or the role of social computing based studies are less. And also we are focusing on the English studies published in English language, so other languages are ignored. If we add such studies also, we can improve this quality of the paper. And also the publication is limited to final, so the article in press papers were excluded. This is one of the limitations of this study. And we can draw future research topics based on the result, that is longitudinal analysis of rural entrepreneurship development can be expected in future. And also make the contextual analysis, like how the rural resources, infrastructure, culture impact will drive the social computing that we can focus in the future. And also how the public and private collaborations for the rural ecosystem that we can also see, we can expect this kind of studies in the future. And the digital divide closing in rural areas for the enhancement of interconnectivity and also digital infrastructure is understood in regions can be possible in future. And also the contribution to sustainable rural development, how the rural entrepreneurship focusing on the sustainability while adopting social computing can also be expect in future studies. So these are the references that we are referred for writing this paper. Thank you.
Alka, did you refer to any recent papers for this particular topic?
Yes, ma'am. 2022 published papers I refer, ma'am.
Okay, because in your review where you mentioned your review, I could not see any recent papers there. Because see, last paper
One
that you have
thing.
referred is of 2020. Because what I feel like is, if you're going to refer to the current papers, this rural thing that you're mentioning, no, that social development or social computing is not so evident in that particular area. I think if you're going to refer to 2022 papers, I'm pretty sure that this would have evolved.
Yes, ma'am. Yeah.
Because even in today's age, I don't think that this rural area would not have been explored or this social networks. Instead of this, you could have used the last topic that you mentioned. No, just jump to your last slide.
Means future research direction, ma'am.
References. Just before the references, the last slide where you had
Yeah.
mentioned your future work.
Yes, ma'am.
So here you have written no sustainable rural development. So instead of focusing
Yeah.
on this social development, you could have focused on this sustainable rural development because currently I feel
Yeah.
like that this is the more topic of
Yeah.
concern.
Yes, ma'am.
Okay, fine, Alka. Anisha, you may
Okay.
proceed with the next paper.
Thank you, ma'am. We'll be proceeding with the next presenter. We have with us paper presenter Vishal J with the paper titled IAM Dataset Based Author Identification by Convolutional Neural Networks. You may please start with the presentation, sir.
Yes, ma'am. Is my screen visible, ma'am?
Yes, ma'am, sir, it is visible. Please continue.
Uh, Good morning, all. My paper title is IAM dataset based author identification via CNN, Convolution Neural Network. Abstract. Image processing, it is in everywhere. It is known as optical recognition in shop, in mall, each and everywhere. Character recognition plays a vital role. In our paper, we are going to present character recognition with IAM dataset. It is a benchmark dataset developed by Kaggle. For this, we are combining the deep learning technique in the CNN. For this, we are using pre-processing technique. Then introduction. Text is in everywhere. Document, newspaper, faxes, printer materials, written notes, poster, wall, each and everywhere. For computer, it is just scan the document. Man can able to see, but computer, it need to extract the text from the scan document, and after that, it need to identify. And for literature survey, we are going on with many literature survey in various different aspects. First thing we are going on with CV, computer vision. It is a part of AI. In this, character recognition, object detection, edge detection, and autonomous driving are performed. Then convolution neural network. This paper present about 10,971 species of bird, butterfly, moths, 490 variety of aircraft, and 525 different dog breeds were classified in this paper. Here also they are using computer vision. In this computer vision mainly focused on many things like crime, surveillance, etc. For next literature survey, we are going on with the Tesseract format. In this Tesseract, first it going on with English. For English, it have better accuracy, but while going on with Chinese character, the accuracy become ranges to 4% accuracy. Because Chinese character will have many different letters and alphabet. It is a little bit complicated. For that, here they are using pre-processing technique. After that, accuracy becomes to 94. Then another one literature review paper, they suggest that Ray Smith proposed Tesseract OCR in 2007. And next, they are going on with Navier classifier and KNN machine learning techniques for using character recognition. Then they are going on with LSTM. Here, from our literature survey, we found out that computer vision, Tesseract, machine learning algorithm, RS, RNN, LSTM, we had found out that we are going. These are very good algorithm, but we are going on with deep learning in convolution neural network algorithm. For dataset, we downloaded from Kaggle. It is a 1999 dataset. ICDR published this IAM dataset. Since it's a benchmark dataset, we are going on with that dataset. In this dataset, there are totally 4 things: test code, writer ID, passenger ID, and sentence ID. In this, for every author, there will be several number of images written in his stroke. Then our process. First thing, image collection. For this, we are using collecting from Kaggle. Then image processing. We are going on with horizontal range, shear range. Image augmentation. It is upsampling. Then creating the neural network. For evaluation, we are going on with accuracy and loss. For creating the convolution neural network, this is our process. Convolution layer followed by one pooling layer, then one batch normalization, dropout, flatten, dense, and output. Convolution layer for compressing the image. Pooling layer for reducing the dimension. Batch normalization is performed to normalize the value, while next dropout is performed to removing the unwanted layer, flatten to give all in the straight layer, then dense layer. This is the final layer. We are going on with authors, total number of authors, and here we are using various paper more than 2, so we are going on with softmax. Then the output layer. This is our architecture. One convolution followed by one pooling, then flattening. This is data augmentation of CNN model with dropout layer. This is our table classifier. CNN model data augmentation of CNN model with dropout layer, CNN with only dropout layer. For this, we are going on with various optimizer, and we are going on with accuracy for 100 EPOS and validation accuracy. This is our accuracy and loss for simple CNN model with 4 optimizer. This is accuracy and loss graph for all optimizers in data augmentation of CNN model with dropout layer. Here we concluded that we are using 4 different optimizer in 3 models, but this can be improved by adding many number of images and train using NVIDIA or some nanostick. And author identification will play an important role in forensic, especially in the place of crime. That's all. Any questions, ma'am?
Vishal, this is your initial research? I mean, you haven't done very detailed research, no?
No, ma'am. This is our first paper to publish, ma'am. And our idea is just a simple, ma'am. We to create a model in CNN. That's all, ma'am. With several optimizers.
With several optimizers. And what would be the purpose for which you are going to use it?
The main purpose is to identify to recognize the character. If some handwriting is there especially in the place of crime or some unwanted area, from the images we need to understand whose handwriting it is.
So you are going to be developing a new CNN model for handwriting recognition.
Yes, ma'am. For author handwriting recognition using CNN in DL, deep learning.
Okay. Okay, fine, Vishal.
Yes, ma'am. Any questions for participants? Okay,
Thank
ma'am.
you, sir.
Thank you, sir. Thank you.
We'll be proceeding with our next presenter. I'd like to invite Heri Shah to present the paper titled IoT-based smart car parking agent using Raspberry Pi. You may start with the presentation, ma'am.
Yes, ma'am. May I audible?
Yes, ma'am. You're audible.
Ma'am, is my presentation is visible?
Yes, ma'am. It is visible. You may start.
Okay, ma'am. So my good morning, everyone present over here. My paper title is IoT-based map packing agent using Raspberry Pi, and we are 3 authors in the paper. Paper ID is 105. So today I am going to talk about my paper. This is the outline that I am going to cover today. So this paper concentrate on what is the problem in this urbanization, as in today's world there is a number of increasing in the automobiles, and one cannot find a good parking during the hectic hour, like in the morning and like during the rush hours. So first of all, we have focused on the challenges that in today's era they face, like growing challenges of parking in urban areas due to the increasing number of parkings. So, and also we have like introduced with the solution that one can use the model to solve this problem using some IoT devices and IoT concepts in today's cities in to make it more efficient in parking management. What is the motivation and objective behind it was
Haley?
to improve.
Please do the slideshow. Your only title slide is visible.
Okay, ma'am. Yes, is it visible, ma'am? Hello.
Yes, ma'am, it is visible.
Okay, ma'am. So like what is the motivation and objective behind it? It is like it improves the urban parking. Also with IoT and with modern solution, we can make more efficient than using some IoT devices like Raspberry Pi and sensors. It gives more and more accuracy, then simplifies, like we won't work on the data that we are feeding, but on the real databases we are working on it. And also it can help in today's era to reduce the parking, to reduce the traffic, and to reduce the congestions. Then component selection. So we have chosen a Raspberry Pi, Pi camera, ultrasonic sensors, and cloud for storing each and every moment that is captured in the Pi camera. Also, Proteus design suite and Tinkercad to design our whole circuit. Why we are using Raspberry Pi is Raspberry Pi is one kind of monitor we may have, like using a typical monitor can be more cannot be more cost efficient, but using Raspberry Pi can be cost efficient too. Also, it has more processing capability than others, and also it is wireless connectivity. Like if we need to portable from one to another place, then it can be easily can be done. Then system configuration, we have Raspberry Pi camera and ultrasonic sensor for sensing each and everything. Like when there is a car, then we can detect it from ultrasonic sensor and Pi camera. And Raspberry Pi is for processing, and cloud is for the storage. And whole network is being connected to a network that is connected with the Wi-Fi. So each and everything is working on the real-time basis, and everything is happening on the moment. What can be the advantage one can have from it is like optimize parking space usage, then reducing search time, like on the like at time of hype, like office hours, one cannot find the parking, so one can reduce search time. Instead of using this model, they can directly can reach on the spot where the parking area is empty. Then secondly, traffic congestion. As we can see when we are moving to the mall, one can see that there is so much car traffic and congestion. So if one is having the model, then one can improve this, enhance experience by minimizing effort, like by wasting all the time, like in the morning just to find this, we can minimize effort and also have like time, will save the time. In also can use such technologies of IoTs to have an amazing experience. And it is cost relevant too, because similar kind of project is also in the existence. One Zurich-based company is also having this, but it is not cost efficient because they are charging millions of dollars per year. But as here we are using Raspberry Pi, which is cost efficient, we can afford it. This is the methodology. Like there is a sensor, ultrasonic sensor and Pi camera. So when we have fed our whole code into Raspberry Pi, as I have previously mentioned that it is a monitor, we have fed that program. So using CV2 library, we will have all the characteristics of car. So once it will have that yes it is car, so it will be sensing okay it is car. Then from on the second hand, sensor will sense that okay something is present, like through the ultrasonic waves, yes something is present on me. So both result will be having AND gate, and it will be finally showing that okay, because in some case what happens that if a dog is sitting on the sensor and sensor will sense that okay, something is there on the sensor, but pi camera will tell no, there is nothing there is no such substance like characteristics of car, so it will give 0. So by doing AND gate, when the AND gate will having the answer 1, it will be generating that okay, parking car of like parking is occupied, and car will be detected in only case when camera and sensor both will be having similar result. So this is the flow. Like when first of all, when Wi-Fi will be connected, Raspberry Pi will be like connected to the cloud, and by processing with the algorithm, first of all camera will detect. After detecting from the camera, if it is found, then okay, we'll be going with the sensor, and if sensor will be detecting yes, something is present, then only car slot will be alerted, and only then it will be shown that car slot is allotted. No other car should be allotted that same place, and otherwise it will show that it is vacant. Then this is one of the image that we have took from pi camera, that we have shown all the characteristic, and it has shown as result that okay, parking occupied. Future scope, like in IoT there is less security, so we are trying to achieve the security so unauthorized access can be removed. Also we are trying to design a algorithm or implement machine learning algorithm that makes more accurate, and also we are trying to make it more accurate. These are like conclusion. So there are some like this can be so much helpful in today's era, but we are trying to uh, become more and more accurate towards our project, also towards our paper, because in research work there are some error we have found. Like if one car is watching that okay, I need to go on this lot, but if they are not reaching, and similar the second car is thinking okay, I need to go on that place. So in these case they are facing some error, so we are trying to solve this. Okay ma'am, this is from my side. If you are having question, let me know.
No questions. Anisha, you may proceed to the next paper.
Okay, ma'am. We'll be proceeding with our next paper presenter. I'd like to invite Kumati Uday Kiran Reddy to present the paper titled Machine Learning Powered Car Recommendation System, a content-based and collaborative approach. You may start with the presentation, sir.
Sure, ma'am. Thank you. I hope my screen is visible.
Yes, sir, it is visible.
Yeah. Good morning, everyone. I am Uday Kiran Reddy. I will be presenting our research paper, which is Machine Learning Powered Car Recommendation System, which uses content-based and collaborative approaches. And we had authors of Mr. Nitin Rawar and me and Lohit Sai as our authors. The basic outline of our research is from title and aim, objectives, methods and methodology, design, block diagram, implementations, expected outcomes. It goes in this way. The main motivation for our research is to establish a structured software that is used beyond limits, because nowadays people are having their own perspective in getting new car recommendations and even having their sorry. Is there a problem?
No, sir, there's no
No.
problem.
Okay. It introduces a perfect solution for having a diverse varies from having one-to-one solution for recommendations of cars, because one provides us data which is there according to their systems, but it is not structured, and it is not even perspect to one user. So we are using a recommendation system that involves a structured input and gives a particular recommendations that which is required for each user. So the objectives of our research are, which we used for our implementation, are to review literature on machine learning algorithms using various recommendation system, and we arrived at a design specification based on our structure which we required for our research. And we used some techniques, and I can highlight this issue and this thing, because we used our own data set, and we implemented using tools which are using some JavaScript libraries and beautiful soup, which made us to implement our research. So these combining all these machine learning algorithms, we made a
I would
better.
like to interfere in between. Just how you said you have used your own data set. So how did you get your own data set? Because it's related to parking, right?
Yes, ma'am. I would like to clear with this. We had, I already know, I mentioned that we had already a competitor for this domain, like Kadeco and all this, but they are using the data sets which are outdated, and they are not even updating there itself. And we are using a data set which is recent most, and which are the cars which going to release, and we are going to update it each and every iteration. It will be in an iteration manner. And we used
Oh, no,
all
but
these
then
techniques to scrap the data.
it can't be your own data set, right? Obviously, you have used certain ready-made data set and then you are manipulating it according to yourself, right?
No, 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 ma'am. No, no, ma'am. We have taken in a
Right?
consideration of segments or segments of cars like SUV sedans. Okay. And we have taken data from dealers. Okay. From dealers, and which are providing manufacturers who are providing their data from of cars, which what they are giving. That is where we are required.
But then how can you call it to be your own data set?
Yes, ma'am. It is not own data. We created our own data set. I said, like, it is.
Yeah, you should
That
say
is correct.
it is the
Yes,
creation, right?
yes,
It
yes,
can't
ma'am.
be your own data set. Your
Yeah.
own data set means that personally you collected the data set, and data set collection, obviously that means you would have implemented some system in your organization, and
Yes,
then
ma'am.
only the data collection would have taken place.
Yeah, yeah.
So kindly use the correct statement.
Sure, ma'am. Okay. And with that data set what we created, and we implemented machine learning algorithms using a hybrid approach, as I mentioned, and we used it for better recommendations compared to others. These are the steps that we've gone through, which is first initially literature survey, and we had our design specifications, and after that we had web scraping, and we implemented our model into a interface that we use as a web application, and we implemented it using of machine learning algorithm that we have a Flask approach, and with that we implemented two interface, and we evaluated using confusion matrix and other standard metrics. This is our basic design, which takes input from the user, and it uses two modules, which is content based recommendations and item collaborative filtering. So with that modules, it gives a weighted recommendation model, and based on that it recommends the cars, which is the final output for a user. And this is high level diagram, which using a data set, we pre-processed it, and through dimensionality reduction we reduce the data which is required for a recommendation. So based on item based data, we had split it into two types, the training data and test data. We had 70:30 ratio here, where we had four types of metrics that we used for getting accuracy, which is multi-class neural network, multi-class decision forest, and logistic regression, as also support vector mission. With that, we tested and we train the models. So based on user input, we are giving output here. And this is our implementation. With implementation, we used HTML and CSS methods, and we implemented it. So here, this is our implementation code that we had for front end, and we used CSS for designing the page. And this is a main file that uses JavaScript and that which helps to render our machine learning model to a front end using jQuery. For backend, as I mentioned, it is a machine learning model which we implemented into a Flask application. Through Flask, we render a template that is going to recommend cars for the user from taking input as a budget and body type and maintenance cost. These are the results that I discussed earlier, which used for accuracy testing. Here we have test accuracy and train accuracy for each experiment. For this, we used multi-class neural network and multi-class logistic regression and multi-class random forest and support vector machine. Here we got highest output for random forest because it is suitable for our model and it gives more accuracy for our testing. And this is our confusion matrix which we used for our each and every evaluation metric here. This is our front end which used for taking input from the user, which is our base platform that gets input from the user and gives recommendations. And these are all the types of brands that we are going to integrate our model. And this is our recommendations after user enters the input, and this gives the output for the user. Here it gives the direct variant instead of giving a set of cars which are under that segment. And this is our visualization of a data set which we used for our purpose, which the data set which we have, and to establish a great command of our data and to have more command on what data we have and what we are going to use for our model. With this, these are our references. Thank you, ma'am.
Thank you, sir. Ma'am Priyanka, would you like to ask a question?
No, Anisha, you may proceed with the next paper. I've already asked.
Sure, ma'am. We'll be proceeding with our next paper. I'd like to invite our paper presenter Swati Vai with the paper titled YOLO V8 Advancements in Innovation in Object Detection. You may start with the presentation, ma'am. Ma'am Swati.
Yeah, good morning, ma'am. This is Dr. Manoj here. I'll be presenting the paper. I'm also
Sure,
one
sir.
of the author.
Sure, sir.
Yeah. Hope my screen is visible.
So it isn't visible yet. Maybe you can
Okay.
try once again. It is visible now, sir.
It is
Please
visible.
go ahead.
So slideshow is visible.
Yes, sir.
Yeah, thank you. Yeah, good morning to one and all who are present for the review. So this myself, Dr. Manoj. I'm a professor in computer science, working in Gopalan College, Bangalore. And my author, one more author, Dr. Swati, who is working at CMRIT as an associate professor. So I'll be presenting the paper. So our title is version 8, where we are going to discuss about the advancements and the innovations in object detection. So the agenda for this paper, we start with the abstract. We'll go with introduction, a basic introduction about the algorithm and the literature survey and the process of version 8 of YOLO and the data set which we have used and what are the metrics we have considered to tell the effectiveness of the current version and what are the strengths, challenges and limitations we have. And finally, we are going to give the conclusion about the current version. And coming to the abstract, so we have algorithm you only look once. So that has been known as YOLO, algorithm. It is mainly used for object detection in computer vision. And the latest version is version 8, which is already available. Here it is, ours is a review and a survey paper which highlights the advantages which we have in the current version when compared to the previous versions. And it mainly deals with a number of iterations with the algorithm. And the recent developments in this version 8 will be discussed with future directions. This paper begins with describing the principles, how it differs from the previous versions with respect to innovations that are introduced in this particular version. And also we are going to discuss about the innovation address some of the limitations of previous versions which we have. So overall, what I want to conclude with this abstract is we're going to discuss about the future directions, potential future directions with this current version when compared to the previous versions. And introduction, as I mentioned, it is an object detection algorithm in the computer vision. It gives a real-time and end-to-end approach to object detection. In a different, unlike the traditional algorithms, so it has a sliding window or a region proposed based approach. So the input image will be, it will be divide the input image into the grids, and each grid cell is bounded into boxes, and class prohibits the probabilities for objects within the cell. So this is a brief introduction about this algorithm, and this is a complete versions of algorithms which we have. So we started with the first version in 2016. It has been introduced with a single neural network, and it can perform the object detection. And the next version was version 2 in the year 2017, which is the advanced version compared to 2016. And they improved the accuracy by introducing the batch normalization and multi-scale training. And version 3 is in 2018, the further improvement of version 2 with the introduction of a pyramid network and dark net with the backbone networks. And we have version 4, which has several innovations, which includes pan path aggregation network and also the backbone network. And we have version 5 for here, which developed in 2020. So we have an algorithm with a significant improvement in the previous version with a novel architecture and data argument techniques with better training methodologies. And version 6 was introduced in 2022. So here we, in the terms of CNN, that is convolution neural network architecture is used in this particular version. And later, before version was 7, which was in 2022, it is developed to further improvements in version 2 using the effective loss function called total loss. And the latest version is version 8, which is already developed. So while introducing several new innovations, it has a dynamic anchoring mechanism, future aggregation module, and attention mechanism. These are the features which I'm going to discuss in the next slide, which are the advantages or the future enhancements which have in the current version. This is a brief introduction about all the versions. And this is a literature survey or literature review, which I referred a few papers to get some knowledge or to get some information about these versions. These are the few papers which I referred. And coming to the process, as I mentioned, it is mainly, it has new innovations to improve the accuracy and performance of the object detection. For this, these are the following outline, like innovation designs. These are the following parameters we have considered. So dynamic anchor mechanism. So the dynamic anchor mechanism is a new feature introduced in this version that is dynamically adjust the anchor size based on the input image. This mechanism enables the algorithm for a better detection of objects of different scales. So it was a limitation of previous versions. And coming to the next one is the future aggregation module. So this is also a new component introduced in the current version where the aggregate features with multiple levels of future pyramid network. This module improves, this particular facility improves the accuracy of object detection by combining features from different levels. So which enables algorithm to detect the objects at different scales. And coming to the next one is the attention mechanism. This is also a new component introduced in the latest version. This learns to focus on important regions of the image. That means this mechanism improves the accuracy of the object detection by following the algorithm to selecting attended of regions, a specific region of that particular object. So these are the few innovations which have advantage, as I mentioned. So one is dynamic anchor mechanism. future aggregation module, and attention mechanism. And these are the data sets which are available, and we are used the first one, common object in context COCO. This is a data set we have used to get some few results. So on evaluation metrics, so mainly we have taken mean average precision. This is nothing but how fastly the object detection evaluation will be happening, and also recall, recalling method, where we can recall the visual representation of the trademark between the precision and the recall, and the speed, how fastly we'll get we call that as in real-time performance and the efficiency. So by using COCO data sets, we have evaluated these are metrics we have followed. And these are the comparisons. If we see the algorithms which we have compared, the latest version with the other algorithms. So the comparison tells that the current version has more state of art algorithm and is faster in this SSD and effective thing. And this comparison we consider the metrics for all regional recall curves and different thresholds which we have. So the strength of the current version is accuracy, real-time performance, and simplicity. So accuracy, compared to the previous versions and other algorithms, so the accuracy rate is good in this particular version. And the real-time performance, as we see, the efficiency is also good. And also it demonstrates the inference speed of 25 milliseconds. So the result, it is more effective and compared to the other versions. And simplicity follows one-stage detection paradigm, making it simpler to implement and understand compared to two-stage detections in the faster CNN. So challenges and limitations, obviously, like accuracy versus speed. So there is always a challenge discussing the trade-off between model accuracy, detection speed, and especially the critical real-time applications. Size and complexity, addressing the challenge related to model size and computation requirement, particularly in edge devices. So, and also ethical and privacy concerns, discussing about the ethical implementation, privacy concerns related to deploy the current version in public and private spaces. There's also a challenging thing, and it can be a limitation as well. Robustness, like exploring the model's robustness and reliability across various environmental conditions. So, for example, low light, if there's a dim light, how to get it implemented based on suppose there's a fog. So how to object detection. So that's also a challenge and can be a limitation. Small object detection, suppose we have a very small object detections where the pixels are very small, the grid size is very small. So that's also one of the challenge. And handling like struggle to accurate the detection in practically hidden by other object. Suppose the hidden object is there, partially it is covered, and so that is also one of the challenge we may face, and it can be a limitation of the current version. So with this, I just want to conclude. So just to revise, like we have the better performance, accuracy with the current version when you compare to the previous versions which we have, and few algorithms which we have discussed. And also we have few challenges that will really help to take forward the review or the survey on the current version, which can be the other latest versions. So these are the references which we have referred to get the things. Okay. So thank you. Thanks for the opportunity. Any questions? I'm open for the questions.
Thank you, sir. Priyanka, would you like to ask any question?
No, you may proceed with the next paper.
Sure. We'll be proceeding with our next paper. I'd like to invite paper presenter Vedant Mare, who wasn't present previously, with the paper titled Creation and Deployment of E-Commerce Magento Website in AWS Cloud. You may start with your presentation, sir.
Are you able to see?
Yes, sir, it is visible now.
Yes. Thanks a lot for giving your time. So my name is Vedant and I am final year student of GHRC College of Engineering. So today we will learn what is Magento and how can we deploy in a cloud environment. My my guide is Dr. Pankaj Chandan Khede sir, and my roll number is 13. Okay. So now second. How to go to next slide? Are you able to see now?
So only your first main slide is visible.
Okay. Yes. Stop here. Now I will open second another image. Yes, it's second one. This. So it's a intro of each. Magento is nothing but a e-commerce platform. As you know, in our India there is two large competitor of e-commerce. It's one is Amazon and second is Flipkart, but they're having their own development center. So what to do with small kind business like Haldiram, Puma, Nike? They also want to their own shop own e-commerce. So these kind of people Magento help. So and from them they can easily store their all the product in direct by them site only. They don't need to go another sites and giving the cut of retailer. As you know, the Flipkart and Amazon taking the cut of it, so it's better to do for your own. Okay. So next. So this is the history of Magento. So it started in 2008 by Variant, a web developer based company is Los Angeles. This is a architecture of is means the application of store, and Magento is totally based on the cloud application, and it's having flexible scalability and customizability. We will in next slide we will check those all thing in detail. I'm audible now perfectly.
Yes, sir, you're audible.
Yes.
Please continue.
So Magento 1 is released in 2008 by which platform, but it's having some lot of this difficulty to set up in local environment. So they slightly move it in the cloud environment. There is Magento 2 and Magento 3. So today is 3 running, and all are their development center is the application is based on all product is kept only Magento 3.
Vedant, can you directly jump to the implementation part as
Yes,
to
yes,
how
yes.
did you implement this Magento in your AWS?
Yes, sure. Just here. So this is the steps for creating. We just need to set up a server and then run by the side. Just create run account is button is there. If you went that main site and then next, and it will done. And just we need to give the credential of AWS server which we already created in middle, and then it will continue by that create account and continue button. And next is okay. Also I will tell the system requirement which it's need to be implemented. It's very important for it. So this is the system improvement. It's totally based on Linux. We are not able to do it in Windows because Windows is easily hackable, and it will hang. So a web server is Apache 2.4 or Nginx 1.8. As people as the convenient of our developer, we can adjust. And MySQL latest one we are using like 10.5 or 10.3 is latest one, and PHP it's 8.0. The minimum it's required 2 MB of RAM space and disk space of 2 GB, and Composer also install an SSL certificate. SSL certificate will stop the voluntary attack from the hackers, because it's an online store and a lot of people are saving their data. card data, so it must be it should be secure. And Elasticsearch server it's help to give exact search whatever in suppose in Amazon we are doing boat headphones, so exactly it's directing to boat headphone, not other kind of headphones. So that's such improvement will help by Elastic server. And okay, I will not cover all the things. And its last deployment process by the console. After this all the things, you want to go to console and download the latest version of it, exact of Magento files and web server, set up the permission, ownership and instruction, and it will install. So just one last. Yes, thanks. This only. Yeah, you can ask me any question.
Vedant, what was the purpose of this installation of this Magento in AWS Cloud? Why did you install
Yes,
it?
cause first we are doing in local system, but local system anytime it got hanged and giving lot of other difficulties. That's why it's moved to the cloud. From the cloud, it's too much fast and easy to browse also, and it's reliable also. That's why we move it to cloud. This application.
So your main purpose was to collect the e-commerce data?
Yes, miss. It's a just store of e-commerce stores. If
And why Magento only? Because there are other platforms as well.
yes, if we go with other platform like that Flipkart and Amazon, they will took cut of it. If you having your own product, like if you having your own mobile phone, and if you sell from the Amazon, so they will took cut 10%, 15%. So for reducing or stopping that cut, we own our own development, own e-commerce website by the help of Magento. So that's the purpose of main Magento.
Okay, fine, Vedant. Thank you.
Okay, now thanks a lot, ma'am. Sorry for the trouble.
It's all right,
Thank
sir. Thank you. We now proceed to the conclusion of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2024. I also thank our session chair, Dr. Priyanka Sharma, for chairing the session. Thank you for your valuable presence, ma'am. I kindly request all the participants to switch on their camera for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe and take care.